This is University last semester question paper for the subject antennas and microwave engineering. So I'd like to solve this question paper. First, let's start with the part A question. So the first question is calculate the far field for a half wave dipole antenna operating at a frequency of 300 megahertz. So this is related with the antenna field zones. So it consists of two different types of fields, near field and far field. And in the near field, you have reactive near field and radiating near field. But in the question, they have asked about calculating the far field. Okay, so the other name for far field is Fraunhofer zone. So that can be calculated as R2, the radial distance R2, that is greater than 2d square by lambda meters, where d is the dimension of the antenna. So here the antenna mentioned is half wave dipole antenna. So for the half wave dipole antenna, the dimension or the length is taken as lambda by 2 for a particular operating frequency of 300 megahertz. So you should know the because in this formula used we have only lambda and this d. So we know the formula for this. So using this formula we can calculate. So this R2 is equal to 2 into d square. Instead of d, the dimension of half wave dipole, you can put it as lambda by 2 the whole square divided by lambda. So we can write it as 2 into lambda square by 4 divided by lambda. So you get cancelling this lambda and this 2 times. So you will get it as lambda by 2. So if you know the value of this lambda, then you can calculate the radial distance. So we know the relationship between the frequency and the lambda. C F is equal to C by lambda. Okay, so frequency is given as 300 megahertz. So I can put it megahertz means 10 power 6 hertz. Okay, this is our given frequency of, and we know that C is the speed of light. So it is 3 into 10 power 8 meter per second. So I can calculate the lambda as C by F, right? It is 3 into 10 power 8 meter per second divided by 3 into 10 power 8, right? So this is 1 meter. So now I can substitute this in this result of this R2. R2 is equal to lambda by 2. So it is 1 divided by 2. So that is 0.5 meters. So the answer for this is 0.5 meters. This is the answer for the particular question. I have given her and I asked her to write. So she had written this, the zone region very far from the antenna field zone is known as far field. It is also known as, I don't understand what she had written here. Actually, you should write it as Fraunhofer, right? Fraunhofer field. And for the halfway dipole, it is given by, she has used this notation, I don't know where from she referred, but the answer is correct, lambda by 2, right? She had written it correctly, and she also got this as 0.5. So this is correct, but she should have mentioned this meters. Okay, then only it is completely correct. You can tell me how much marks can be given for her. If I have corrected, I could have given her 1.5, or I can give her 2 marks.